anyways, just trying out some new gear. Although I had this for a while, I just haven't used it because of, well, everything's online, and so I could just use my other mic, which usually has better quality, but I wanted to make sure this worked for the return to glory on campus classes. But anyways, so real quick, I wanted to go over a bit of an example just to highlight a lot of the key ideas that we encountered throughout the last few weeks. So here we just have code, and so we're going to trace through it, we're going to diagram it out, and make sure that we have a clear understanding about what's going on and how this code sort of plays out when it's executed. And so, okay, let's just take a look at a few things. So here within main, it looks like I have this string array that begins with two types of deliciousness. And then I have this thing called taco box, which is presumably above or defined above. And then so I have this longs tacos, which is a type of taco box. I'm passing in the type of tacos that I want and some numbers associated with the constructor. We'll take a look at that later. It looks like I have some function here in which I can add some, or just modify my order in certain ways, just change it up so it's not the same bit of. And here I'm just kind of leaving this amorphous because the details aren't important. I'm just going to reflect what this does in terms of the picture. Again, whatever the implementation of this function is sort of besides the point. I just leave it to you, your imagination that this does what I'm going to reflect within the picture. I just don't want to sort of fuss over the details because, again, it's not important. Molly also has tacos, just a bunch of fish tacos again, and so we pass in this for her order and a bunch of numbers that we'll see in a moment. And it looks like here is another taco box. It's called a troll order, in which is invoking the default constructor. And so let's take a look at what these things are. In particular, let's look at the definition for a taco box. And so here we see a class taco box. Looks like it inherits from a box. Okay, maybe that becomes relevant later, but okay, so we see that there is the default constructor where it looks like, well, let's first take a look at our member variables. That way you can reason about what this means. It looks like we have a definition of a taco inside our class, and so this might be different, although it's really functionally no different from this being defined elsewhere. The only restriction in terms of, or what happens when you define it within the class itself should be somewhat obvious, is that the usage of this taco is only defined within the class itself, right? So I'm providing the definition here, but it's private within tacos, and so presumably you can't order single tacos in this universe that we're creating, which is whatever. If you do want to have single tacos, then we could move this outside. Here, I just want to put this here just to illustrate that you can do things like this, where you effectively have nested classes defined within each other. And then the intent here is that or design here is that only taco boxes can manage tacos. And so we have this data type defined here, and it looks like we're defining a double pointer of type tacos. And so presumably this is going to point to addresses of tacos, or rather pointing to things that point to address of tacos. And so we'll take a look at that. It looks like when we take a look at the implementation for the constructors, looks like we have num type. And so presumably this is with regards to this, right? So it looks like long is ordering two types of tacos, and so this 2 is probably, or one of these numbers associated with the number of tacos associated with the order, and then number of each. And so presumably he looks like the 2 and 2, so it looks like he has two types of tacos and 2 of each in his taco box. Whereas Molly looks like, if you take a look at the parameterized constructor, so the first is the string array. So this takes the names of the tacos you want for your order. This takes the number of them, and so this is kind of like the size of this. So this, which is what we always do with arrays anyways, and then also number of each. And so the third parameter is the each thing, and so it looks like long is creating two tacos, birria and carnitas. I can't trill my R's, and so I apologize for that. And then 2 of each, and so it looks like long will have 4 tacos total. Molly has one type of taco, which is just fish tacos. Okay, she likes fish, and then she's gonna have 3 of them. Okay, and so let's take a look at how this will. And then troll order is effectively invoking this because, again, no parameters or no arguments. That means we have to invoke the constructor that has no parameters, which is the default constructor. Looks like one in which it sets we have no types of tacos, none of, well, of anything, and then we don't point to any tacos within the taco box. And so it looks like will be dynamically allocated, and so we're just going to make them on the fly. and then put them in a taco box for which these people can go off and be extremely happy. And so let's go ahead and let's go through this, right? And so here within main, I declare a string. I'm not going to draw this out because it should be obvious. It's just an array of things. From it, draw this out. That's what's important. And so let's go ahead and grab a stylus on the floor. And so boom. All right, so let's go ahead and draw long out. Let's see, scroll. So, okay, so in main, or wherever, inside your diagram anyways, so longs, let's see, maybe I can zoom a little bit. Oops. Hello? There it is. So, cool, scrolling bars. So longs, tacos. Boom. And then so in memory, to construct this thing, it looks like it's inheriting from box, and so there is a base component here. And so if you want to do a bit of review here, right, we know that that involves, in this case, a call to the box default constructor, right? So that's being done. Same thing here as well. Boom. Oh, actually, I should do this just to be clear. Semicolon gets you into initializer list, right? Colon rather. Sorry. And then this also resides in probably something like this if we don't do anything. This ends up being wrong, but when we get to this, we'll fix it. Okay, and so boom, whatever this is, we'll just use the default behavior for now. And so then we go ahead and draw, and understanding that this results in the fact that the base component of taco boxes will be constructed first. And so I'm just going to draw it out like this. Again, it's not important yet. And so I'm just going to draw maybe something like this for the box component, or the base component of a taco box. And then beneath this, I'll do it like this. So this will be for taco box. Capital B, actually. And then let me draw some boxes for the member variables, right? So we have 3 of them. We have a thing called tacos. We have a thing called numType. I need a new nib for my stylus, numType. And then we have numEach, or numia. Sounds like a Lord of the Rings. Yeah, so Numier. Anyways, so, and then let me draw the actual boxes for these values. And so this might look like something like this. Boom. Okay. And let's go ahead and complete this box. This might look like this. This might look like this. Okay, so that constructs, the memory for this, and let's populate this with the things that are being passed to this function. A bit of a lag there, so hopefully it isn't too bad throughout the rest of this video. And so we're passing in these 2, and then we're going to fill it up with this bit of information. So it's going to be essentially 2 and then 2. Okay, let's see how it plays out here. So so that fills out. So we pass in 2 and 2 for types and each. We see that we see out taco box parameterized, and so that will be printed at the console. And then we make a dynamic allocation to an array of 2 taco pointers, right? And so that might look like this. It doesn't really matter how you draw this. I'm going to draw it vertical because it just makes it easier to point to the things I'll put next to it. But again, it doesn't matter if it's horizontal or vertical. It's just somewhere on your paper that you can easily identify. In this case, I'm going to keep track of addresses because we understand pointers store addresses. And so I just want to make it clear that I can easily see the addresses of interest. And so okay, the operating system says, here is an array of 2 taco pointers. So the first element, let's say, is at X. It doesn't matter. A1, let's call this XA2. Again, it's just arbitrary. It doesn't matter what you use. You just have to be consistent that this will always refer to this box, right? So you can't just use random numbers if you mean this thing. Anyways, and so that is to say, after this is given to us by the operating system, that will assign XA1 to tacos. And so XA1 is stored within tacos. And so I can draw an arrow that goes from this to this. So tacos points to that element, or this array rather, but in particular, this element within this array. Okay, and so now let's go ahead and continue on. That's this line of code. Here, it looks like we're looping through each of these, and we're assigning to this an array of 2 tacos. And so each of these pointers will point to an array of 2 tacos each. And so let me draw it over here. So tacos, again, consist of, in this example, just 2 things, but we know that real tacos can have more options. But again, for just simplicity's sake, and so I don't clutter up the picture too much, we'll just keep it with the type of taco and then the type of shell. And it looks like that's by default set to corn, and maybe we can change that a bit later using whatever this function does. Okay, so dynamic allocation, so new array of 2 tacos. And so let me go ahead and just draw that up here. Well, first of all, in terms of space, so we have type and then shell. Zoom out a little bit. Okay, and here's the boxes. These are strings, so let me just, that should be enough space. Boom. Okay, and then let me draw like an overall box that looks like this. For 1 taco. So let me put the type there. And then, so, well, first we need to get this. And so just to kind of make my life a bit easier, let me just go ahead and cheat a bit. Joink. Boom. So here's the first array of tacos. And actually, let me move it down so I can actually add addresses to everything. Boom. And so here, let's say this is at X, I don't know, B1. And let's say the second element here is XB2, right? 2 tacos in an array. So this is the first element, this is the second element. And so now that means I'm going to be putting the address of XB1 when I is 0, right? So this first element into this box here, XB1, and I can draw an arrow that goes like this, pointing to that box. And then let's go ahead and create another, because when, again, so I goes from 0 to 1, num type is 2, so when 1 is less than 2, we do this again for the 1 element. That means we need to assign an address here that points to something that looks like, I won't include the addresses because they'll be different. We'll see, like this, boom. Let's say this is at XC1, oops, let me change the colors back. XC1. I'll call this XC2. Again, these addresses are arbitrary. You can just pick and choose whatever you want here. And this is assigning effectively the first element of this array to this box here, which is what you see with this line of code here. And so XC1, and that looks like not an XC1. Okay, and let me draw an arrow that goes from here to here. Okay, and so now that's Long's taco box. Let's go ahead. Oh, we're not done yet because we need to go through this loop, which simply goes through, looks like for, well, it went ahead before I went to, I should have, before creating this, I should have went through and grabbed the first type, which is birria, the most delicious thing in the world because it tastes like pho. So both of these, so we're going to loop through each of them. So num each, there's 2 of them. Both are birria, and by default, we're just going to start out with corn, which is fine. If you want to be weird, we can change it to flour later. Corn. Boom. And then let's go ahead and do, for the second iteration, we can go ahead and change this to, not change it, but assign to, well, I guess change because these are garbage values, but assign to these carnitas and corn as well. That's carnitas, so hopefully you can just follow along without me. Well, I'll clean it up in case people are kind of can get confused by that. Let me scroll in a bit. So C, carnitas, and then corn as well. Okay, so that's, yep, so that looks like we do that for both arrays. and then we get down to the end of this, so we're done. So we return back to main, and let me. And we go back down here. We see that we modified the order. Okay, and this is just hand waving. I'm gonna just to make this a little bit different, although it doesn't really serve much purpose. And I suppose the only thing we can change here is like we can change the shell to something else. Well, if you, I mean, yeah, it doesn't really matter. So the other option is let me suppose I want to have my carnitas the shell instead of corn. Let's make them flour. So flour and flour. Okay, so that's my taco box. And so they're going to make it, and then I'm going to eat it. I'm going to be extremely happy. Maybe. Depends on how we implement this universe. But let's continue forward. So let's go ahead and do the same thing for Molly. All right, so she's only having fish, so 1 and 3, but 3 fish tacos. And so, boom, let me go ahead and create some space for Molly's tacos. Boom. Okay, and she's gonna look the same, right? Because she's invoking effectively the same function, but exactly the same function rather. And so boom, box component, taco box component. These are not actually here because I copy pasted. And so she passes in fish and then 1 and 3. So num type is 1 type of taco, fish. It will be fish, and then 3 of them. Okay, and so she goes through and, well, she will print this out. She will assign to this an array of 1 element. And so this might seem weird, but you can do it. An array of 1 element is exactly that. 1 element, but it's still an array, so you have to be a little bit careful. It's not, you can't delete it the same way in particular. So you have to use the delete array since you use the allocate array syntax. Okay, and so let's say this is at x. I already use ABC. Let's say xd1, although it doesn't matter. And so this gets xd1. This points to this. And then she goes through each of those, so just once, where she allocates to this box the address of a array of 3 tacos. And let me go ahead and let me do this. Control C right here, and then Control C, Control V. Like this. Of course, these are all fish, right? So let me go ahead and change this to fish, or just blank it out for now, because the first thing we need to reconcile is the address, right? And so this x e1, oops, black, xe1, xe2, and xe3. Okay, and so yes, this gets assigned xe1. It's taking the second pot. There it goes, and then that means I have an arrow that goes from here to here, and then each of these boxes gets the type of fish. 1 fish, fish. Okay, so this is the state of our program so far. Oh, let's create the troll order as well. And so this is, let me go ahead and create this, or rather copy this because I'm lazy. So this over here, this is for the troll order. Boom, capital O rather. Camel case. Okay, and then he just has nothing. It's just kind of a jabate. So 0, 0, and null PTR. Okay. Boom, so that's that. He has nothing. Okay, and so let's see how we can sort of do a few things here. Now, supposing we want to, well, Molly goes around, being as Molly is, she sees that I have a bunch of delicious tacos, and so she wants to effectively have my tacos, right? So she wants to dump her order, right? She wants to get rid of it, or eat it maybe, whatever it is that would translate to cleaning it up, or rather. And then she wants to get an order, a taco box just like mine. And so the way that what that'll look like is, well, we both exist, right? So Long's taco box and Molly's tacos both exist. And so what we want to do later on is let's have Molly's tacos rather. Molly's tacos, she wants to look like me or have the same kind of box I have. She wants to take on Long's tacos. Boom. And we know at this stage that this is invoking the assignment operator, and so we need, well, first of all, if we don't implement something, we get the one that does a shell copy, which would effectively just copy the member variables, right? And so we just have to modify these boxes to reflect the shell copy, nothing else, because that's all a shell copy does. It can't see past the member variables, and so this would effectively look like this. So this becomes, well, because my longs x or tacos is xa1, by definition a shell copy would make this xa1. And again, this is assuming I didn't implement this function or the assignment operator. And so now this becomes 2 and 2. 2 and 2. Right? And then if in terms of the way this is reflected within the diagram here, or even in well, this is supposed to be a reflection of our memory proper. We lose this, so we have, so not only does Molly just throw away her tacos, which is a tremendous waste, she goes so far as to grab my taco box, right? And so this is, if this doesn't trigger you, you need to reevaluate your life, because this is bad. No one's touching my tacos, right? So this is aliasing my tacos. She's grabbing onto my box. I'm grabbing onto my box. This is like a battle of the ages, right? And so as much as I love you, you cannot have my taco box. So this is bad. Okay, shell copy. For this class, generally speaking, if a class allocates something, it owns it, and it doesn't want anyone else, or we don't want anyone else to have access to it, because that leads to a lot of bad things that we talked about in class. In particular, one thing, we lose this, and then presumably once we implement the destructor, there will be issues with who would be responsible for cleaning this up. And so lots and lots of issues. You don't want this to occur in this class. Now, with that being said, yes, in practice, there are scenarios in which you might have multiple things pointing to the same thing, but that sort of confuses the issue, and I'm not going to really discuss that in this class. Just be aware that such things do exist. But again, our life is simple, right? If you allocate it, you delete it, you own it, and no one else should touch it. And in this case, this should be clear, right? So no one should have access to your tacos. That's just a bad time. And so let's go ahead and clean this up and bring this back to the state where it was. Can I? Oh, I can't undo. Can I maybe? Yeah. Oh, maybe I have to undo on the tablet side. There we go. Okay. So PTR. Okay. Everything back to, well, much better than before, but we still need to resolve what this does, right? And so that means we need to implement this function right here. And so at this stage, I'm not going to go through the rigmarole of this being outside. You know that if this is outside the function, you need a scope resolution operator to resolve the name. But at this stage, I expect you to kind of know that by now. But you have plenty of practice problems that sort of force that upon you anyways. And so just for simplicity's sake, let's go ahead and implement it here. And so we know, just in terms of just the pseudocode, because this is never going to change for the assignment operator. Just the way you translate the pseudocode is going to be different depending on, well, what this is and sort of how you handle the member variables. And whatever preconditions you might have with its usage. So we need to check for self-assign. We need to clean up. All right, and so this usually, I mean, the only reason we need to do this is if we have dynamically allocated members, or that's kind of a shorthand of saying pointer member variables that point to dynamically allocated memory, and so presumably delete something, maybe, and so I have to be a little bit careful here. I'm going to make this a bit more general. I know that I kind of hand-wave this idea of edge cases, but I'll make this more as general as possible with regards to, well, at least this scenario, meaning I won't say like you don't need to do, well, I won't say that you'll always have at least one tacos, because, for example, you might have a situation, you have a troll order, and if you try to do the same thing with the troll order and you don't handle this edge case, and again, like the number 0 is typically an edge case for almost everything, right? And in this case, it reflects the fact that you have no tacos, which means tacos is null pointer, which should make sense. And so you need to sort of decide how you need to handle this, because if you, as you'll see, is if you don't handle this here and you try to operate upon something that looks like this, it won't actually make sense. And so we'll get there in a moment. And so regardless, so clean up, and then we need to After we clean up, we need to allocate, right? So this is effectively like the copy constructor stuff. Well, we copy over, we get some information about the other person. So copy, so allocate the appropriate number of things, copy over whatever those things are, and then again, there's edge cases that might exist. Now I throw this here just because the examples that we've seen, that they normally occur here, but there may be edge cases like in a bunch of different locations. I'm just sort of, but again, up until this point, I didn't really want to confuse people because I want you to focus in on things that really matter at this stage, right? Like, well, all of this so far, and the primary things, what's already commented out, which is all of this. The edge cases come along as you become more proficient at one. Well, first of all, you know how to do all of this, and then you can tailor it to any specific code base that you're working on. And then, and really, it's kind of, it might seem complicated, but these are things you probably already dealt with in CS52. And so it's just, when you try to combine everything together, they kind of feed off each other and make it more complicated than it normally would have been in isolation. And so regardless, copy constructor stuff, which is to allocate, copy over, and also edge cases. But again, the edge cases can exist anywhere within this function, and you'll see that play out when I try to go through another scenario after this one between Molly and Long. So edge cases. And then after this, presumably we would have made Molly resemble Long, going through the deep copy, which is what we have to do when, again, you have dynamically allocated members, and then return myself. Again, this is always going to be true, along with understanding the function header being same type, and then return of an object reference. Okay, and so go ahead, let's fill in the details of all this. So let's replace this with the check, where I compare my position in my this pointer to see whether or not it is the same address as the other guy. Boom, if this is the case, return myself. And again, if this is weird to you, just go back to when we first discussed, or maybe the week after we introduced pointers, where I talked about references, right? And so this is an address, and so you kind of have to know that. Return star this. Well, if this is my address and I want to return myself, I dereference my address to return myself, and it always does that for some reason. And so clean up. Okay, and so what do we clean up here? Now, in this example, the things Molly needs to clean up is effectively all of this, right? If we just take a look at the picture, we see that all of this needs to be cleaned up. And so we have to be a bit careful, because I can't clean this up first, because if I clean this up first, I have no ability to clean this up. And so I need to clean the things at the end first, and then move my way up to here. And so I need to clean these two things up. And that should be sort of apparent in the fact that I make two calls, well, in a certain sense, two calls in new here, but there's a loop here, so this is gonna be multiplied by a number of times I iterate. Just like with Long, right? So he has one call to new for this guy, and then two called to new here. And so Long's gonna need to go through, delete this, and delete this at some point, presumably in this destructor, which we'll do next. But before that, let's go ahead and have Molly clean up after herself. And so first of all, she needs to clean up this array, which is, she needs to dereference this address to get to this address, right? And so we need to have her, well, in particular, in general, here she only has one thing, but she does have the potential, as we see with Long, have multiple types of tacos. And so there's no reason why we shouldn't go through for int her, well, potential number of types of tacos to delete them all. Now, given that this member variable here, num type is 1, this will only ever iterate once, and so there's no loss there. So int I equals 0, I less than her num type. Boom. And then, so I plus plus, or plus plus I, doesn't matter. Boom. The compiler will be smart enough to figure out which is faster. And so, boom. Let's go ahead and go through each of her types. And so so delete, and then again, these were all located using the array syntax, and so we must use delete the array at, in this case, well, for the first element would be xe1, right? But we know, capital E, we know that is stored within the first element of tacos, right? So this is the same thing as saying tacos sub I, because I is going to be 0 the first time around, and then if she had more types of tacos, it would iterate through those. And so this is general for, in the case if Molly ordered more than one type of taco. Okay, And so boom, there's that. Now that this is gone, boom, she can now delete this thing that was allocated. And so this is just saying delete the array, the array at tacos, right? Because tacos, oops, boom, tacos is just this box, right? Tacos, this box, xt1, which deletes this thing, right? The array at this address. Okay, and so that cleans it up. And so effectively, in terms of this picture, I can say, okay, this is all gone. I'm not going to actually delete this because I might come back to it. So boom, right? So that's effectively what Molly looks like now. Let me get this out of the frame. Gone, no more tacos. So that's the operating system took it and gave it to some homeless dude. Okay, so now at this stage, there were some suggestions about maybe zeroing this out. You can, if it's necessary for what you're doing here, or rather, if what you're doing here depends on these values, then yeah, it's not a terrible idea to do that. But that's kind of up to you. I'm going to go through it in which I don't need to do that. But again, it's specific to how you choose to implement your algorithms. And so in this case, let's go ahead and I'll leave this here for now because this won't become apparent until I maybe do something with my troll order. But anyways, let's go ahead and have, let's just do this bit where I allocate. And so this is effectively exactly all of this, right? Because this allocates stuff. And then this is probably different because I'm not pulling from the parameters of whatever function this is. Well, in this case, I'm pulling in from the other guy, which is the parameter to the assignment operator. And so the only thing that's different is these two things. And so let's go ahead and grab that. Oh, and also I won't have the initializer list, and so I have to manually assign the num types and num each from Molly from here. So let me first grab this. I won't copy it yet because I need to take from long, or the other guy in this case. So other is a reference to long due to this binding here, right? And again, if just review, right? So this is the same thing. Well, this is actually doing this. So operator equals and passing in as an argument long tacos. Boom. This is just kind of nicer to look at. Okay, and so now we need to me, and so my num type, and again, private. Both Molly's tacos and Long's tacos are the same type of thing, and so that means, despite the fact that these are private, things of the same type can access to privates, right? And all that nonsense. So boom. So num ia equals others num ia. Okay, and now let's go ahead and do the allocate and copy over, which I paste in the code I got from the copy, or just this constructor. I just need to replace it with the appropriate calls here. And so the first, I go through each taco from my num type, and then I go for each of those particular, within each type, I go through each of them. So I will assign from the other individual, right? So it's not this, delete this, but rather I grab from other dot tacos, and so Long's first type of taco, and then the first taco within that type dot type, oops, boom, and then I can just copy pasta this for the shell as well. Incidentally, you could use just the shallow copy assignment operator because tacos don't have any members that point to dynamically allocated memory, and so that would be fine too. But you could also do this if you're just kind of confused about how you would do that. This will work just as well. In fact, you're not even doing anything faster because you still need to copy over the members. So exactly same Z's. Okay, and then after this, so let's go ahead and go through this process. So let me reflect this here, where first of all, what we changed was the fact that num type and num ia are now 2 and 2, so that's these two lines of code. And then we don't alias Long's tacos because again, that's a fist fight. We have Molly request from the operating system, or in this case, maybe the taco stand, a new array of 2 types of tacos, and so this is what this might look like. And then that means, let's say this is at address, I don't know, x01, just to kind of have some different addresses. Let me zoom in a bit so you kind of see a little bit more clearly. Oh, it's a bit feathered. I wonder if I can kind of solidify these things a bit. Or I can get rid of the, well, if I get rid of grid, I won't have any alignment that I can deal with. Hardness, or I can make it thicker maybe. Here we go, hardness. It's not actually letting me choose it. Okay, anyways, so XO1 and XO2, and then we go through each of these within this loop, for which I assign to this an array of 2 tacos, and in this case, I'm just going to copy paste. Right, so boom. But I need to delete some things. So let me do it like this, and let me delete. Let me clean these up first. I mean, I could just copy paste directly because that's what we're doing regardless, but I want to make clear what the steps are in case people want to see all the steps. And so this is at address X, I don't know, 11. This is at X12. And so this gets address X11. All right, so then we go ahead and draw an arrow pointing to this. And then what we do is we go, for this particular taco, we go through each of them, and we get the same things as what long has for this first set of taco types, right? And so boom. I'll keep it in red because I'm too lazy. And then both are corn in this case. So first taco, bada bing for this. Second taco, all the stuff for this. Okay, and so now we go to the second type of taco. We make a call to new, where we allocate an array of 2 tacos. And so we go boop here, and then I'm going to keep this because that's exactly what we're going to do anyways. But understanding that I would read from, I mean, these would be garbage values, right? And then we would read from this to get blah, blah, blah. Now, although that's not strictly true because these are strings, which are objects. And so these would be empty, but regardless, you guys get the point. So this, let's say this is a X21, X22. That means the address X21 is stored here. Arrow pointing here. And then again, we'd go through grabbing from long's type for the first taco, assign here. The shell, first taco, assign here. Go to the second taco, type, second taco within this particular type, and assign carnitas to carnitas and flour to flour. Boom. And now, if we take a look at the image of these two, they look exactly alike. So long has this, Molly has the same order of tacos or taco boxes long does, and this is what you want to look at, right? This is what you want to see by way of just having Molly resemble long, which is what this line of code is attempting to do, right? And so that is to say, in a terrible world, Molly would alias this, which would have been the shell copy, which is bad, right? So hopefully, the fact that I'm using tacos motivates that you don't want to alias your addresses or your pointers in this way, because no one gets your tacos, right? They're their own tacos. Okay, so now let's highlight something. So let's keep all this the way it is, and suppose some dude comes along and starts to troll Molly, right? And says, "You want to have these tacos?" He's all creepy. He's like, "You want some tacos?" Right? He's from the movie Friday. But that's cheeseburgers there, but regardless. And so Molly says, "Okay, yeah, I'm trusting, right?" And so let's go ahead and so the troll order dude comes up and says, "You want these?" Right? And so she says yes, and says, "Okay." He's like, "Here it is," right? And so how would we facilitate this process? Well, it would be the same exact thing, but what we'll see is that the way we implemented this isn't quite capable of handling this troll case, as we'll see in a moment, right? So boom, let's go ahead and go through this, where we pass in troll order as the other, right? So boom, we get down to here, right? So let's parse this, right? So right now, other is a reference to troll, right? And so I could say, again, the shorthand is, you can imagine other just kind of referring to this box as well, because that's kind of like the quick and dirty way of thinking of references, although it isn't quite that. You can take a look at disassembly, you can see that it's much different from what this implies. But in terms of just solving quick and dirty problems, that's the way you can think about it for most of the things. Okay, first of all, so this is, whatever this is certainly not the same thing as this box, right? So this box is not this box, so this is false, right? So we go down to here. Okay, so now for each type, oh, actually, no, wait, I want to do it in reverse to kind of catch this, and then we'll flip it up. Although, no, I'll keep it like this, and then we'll do both, right? First we'll do this, and then we'll just do some weird situation where we try to do not both of them, but we'll switch it up and do the other way around, and now I'll uncover other things as well. And this will highlight when these edge cases come about, if you don't have any preconditions saying that you don't have to worry about them. Okay, and so let's go ahead and implement this. Oh, we already implemented. So here, Molly goes through and deletes these things, right? So for each type, delete the array at x11. So that would delete this array. And then the second time, it'll delete this array. Right, so let me move this off screen. Boom. And then when we get out here, we delete this array. So tacos is just x. Well, this should be, sorry, I didn't update this. Oh, that should be a 0, right? x0, 1. Right, so we delete x0, 1, which is being done here, which would delete this. And let me pull this off frame. Like this. Okay, so now she deleted our things. We can go ahead and go through this where we have, excuse me, num type is 0 from the troll. Num each is 0 from the troll. Let me go ahead and reflect this. 0, 0. Okay, and so now we need to do a few things where dynamically allocate an array of taco pointers of 0. And so this is undefined behavior, and you can't do this. And so here's the first edge case. You can't do this, and so you need to, if it happens to be that if you're trying to do something like this, you need to not do it. And so this is saying we need to include some logic to catch this edge case, right? And so boom. So we only effectively do that. Well, the alternative is when this is 0, then we do nothing. Likely, we just kind of assign these tacos to null pointer, which is really what the alternative is. And so if we have nothing to allocate, so in this case, we could look at num types, right? Because num type dictates or is in line or consistent with the number of elements in this array, right? And so if this equals 0, or maybe you could also ask the same question again, as long as if these two variables or member variables are supposed to kind of represent the same quantity in a certain sense, they have to be consistent with one another. So you could ask this question through num type, or whether or not the other guy's tacos is null pointer. Because if that's the case, then you don't do anything either. So both are the same question with regards to this particular edge case. Because you could ask this, if this is 0, then we don't want to do any of this. All we want to do is set my tacos to be null pointer. And that would effectively have Molly look like the troll guy, right? But no S though. And then this would be all within the else block. Boom. Right, and I said alternatively, a different way of asking the same question is if the other tacos is null pointer. Same thing, right? And then this is the one of the highlights one of the issues between having many member variables. It's highly probable that they kind of reflect the same kind of attribute to the object, and so it is important for any developer to keep the member variables consistent with the intended state. And so that's the way I've been phrasing it, right? And so in this context, if you have 0 tacos, or rather you're not pointing at any tacos, then you must have 0 types of tacos, right? Those two must be true. Because if they're ever contradictory to one another, you can't use this data structure, right? There's no value in it, because you're just going to get bugs all over the place. And so anyways, and then I forgot to return myself. Let me go ahead and fill that up. I was too excited about getting to the tacos bit. Okay, or actually eating tacos rather. Okay, so it's just illustrating the whole edge case. And so now let's go ahead and flip this about. Right, let me bring things back. Oh, I can't. Oh, interesting. I can only undo in this side. Interesting. Oh, well, anyways. So let me actually, I don't have to. I have it here, right? So let me go ahead and grab all of this. Let me revert this back and highlight something else. Let me do this. And so this is x01, this is 2 and 2. Okay, so everything is back to the original state before the troll. And so, okay, so this shouldn't have never happened anyways, because this is just terrible. So instead, though, let's suppose the troll dude, right? Troll order wants to look like Molly, right? So he's like, my life is, this is kind of a bad place to be, and so I want to actually have tacos. And so let's go ahead and take a look at what Molly has, right? So he wants to look like Molly's tacos. Molly's tacos. Okay, and so let's see what happens when we step through this. Now we don't have to go through the whole thing, because I think at this stage you kind of understand the steps. This is just highlighting one more potential area for edge case things that you need to catch. And so, okay, so Molly is the other guy. So let me go ahead and just say just so we have it, right? So boom, other in the picture, and then we don't actually see it. So other, and so now the goal here is troll wants to look like this. He wants all of this. And so before we get there, we need to check for self-assign. Okay, so this box is not the same as this box, so false. Oops. And then we need to, well, first of all, a few things we need to think about. So this is saying what? This is saying go to this address or go to this particular offset and dereference it. And so at this stage, this is where the alarm bell should go off. This is pointing to, there's nothing here. So normally this would go to one of these guys down the line, but that implies that you would have this in the first place in order to do this. But troll order doesn't have this, so he can't even dereference this. So this makes no sense. Right, so this is undefined behavior. You can't do this. And so here's the edge case I was kind of hinting at earlier. So it can exist here as well. Again, it can exist in various locations. It just has to, it depends on your member variables and how you treat them. And so here we only can delete things, well, in particular, if troll order, me, has something to delete. In this case, he doesn't because he doesn't point to anything. And so again, you can kind of think about the various ways in which you want to organize your logic, right, to make it more, I guess, condensed if you like, but it doesn't, you don't have to, right? At the end of the day, it may be more redundant than otherwise, but that's okay at this stage. I'm not concerned about having clean code per se. And so you could say, I only want to do this if I'm not null pointer, and so only delete. So if, and again, I'm kind of flipping the logic, if my tacos is not null pointer, or if then I can delete it, right? Should that statement make sense? If I'm not pointing to nothing, then I can delete it. And again, you can flip the logic. If you are pointing to a null pointer, then you just don't want to do this. And let's see if, and so that will catch this case. And so I don't delete anything because I can't, because that's undefined behavior, because I currently have no tacos to delete. And then I see, okay, so here I just kind of assign to myself, so 2 and 2. 2 and 2. I see that right now the other person's tacos is not null pointer, and so I don't do this. I go through and do this, and it should be clear that this would result in the same kind of picture, right? So I'm not going to go through that though. You can do that on your own, but it will look just like this, just with different addresses, right? That is to say, troll order would have his own box of tacos, not pointing to, he's not aliasing Molly's tacos again, because that's terrible. Terrible, terrible. Okay, and so that's that. Now, I kind of debated you because I kind of left things out on purpose, because while this will resolve copying over things with regards to this box, or this part of this object, right? So the taco box bit, we actually haven't done anything with regards to the base component, which that means in order to recognize whether or not you need to do this, well, first of all, if you drew out the memory appropriately, realizing that taco box is inheriting from box, you would have this. And then you should, in the back of your mind, saying, okay, I'm handling this. I probably need to have this dealt with if the intent of this operation is to have these entities look exactly like one another, right? That's the intent of having a copy, whatever, copy assignment, copy constructor. And so that is to say, we would need to invoke behavior that would facilitate that. And if we work with people who design their code appropriately, like for example, if we look at our code base, we might see that we have something that looks like this. In fact, the implementation doesn't matter, because we would just say someone else implemented the box and I already have these functions implemented appropriately. In this case, it doesn't matter because there's nothing interesting here, but I'm just saying for argument's sake, let's suppose we do have these functions and they're implemented correctly, I can just call them. Even if I didn't implement this, I could still call it, right? So let me comment this out. Boom, boom, boom. It doesn't matter because, well, in this case, I don't need them because these are just scalars, but that's largely besides the point. Oh, actually, yeah, I can't really do it that way. And so the point is, if you realize or recognize that, or you see that you have inheritance in your objects and you're implementing the assignment operator as well as a copy constructor, you need to reconcile the fact that there is a base component that you need to reconcile. And so box, : operator equals, and again, it's just one line of code on top of everything we just did, other. And that's it, right? So this handles it. And again, this is making use of abstraction and encapsulations. This is already being done for us. We just need to call the function that does it. Boom. And then again, I kind of left it out here. Where is it at? So this is that. We probably need to do something here. which is, again, if we, for the copy constructor, same bit. Well, this would be this nonsense, right? So Control C. So the copy constructor would look like this, right? Brand new. Oh, this is the exact same code. I want to look like the other guy. As long as he's not null pointer, I can go ahead and allocate and do a bunch of stuff. And then so, but now if we leave this blank, right, this would make an attempt to call the default constructor, which is bad. And so instead we need to call the appropriate copy constructor by passing in the other thing. And since we had the lecture, this works because of polymorphism, right? So if you look at this guy, as long as you have a reference or a pointer base thing, which this is, referring to or pointing to a derived thing, this makes sense. You can do this, and C++ will make the appropriate calls to the things that matter. Okay, so that's that, right? So that's not only implementing assignment operator and copy constructor for objects, but also objects that inherit, right? Because, and again, when you see this, you just know that you need to do one more thing in both the copy constructor, simply just call the appropriate copy constructor in the initializer list for the box or the base component, and then for the assignment operator, invoke the parent or the base version of the assignment operator, right? And then you're done. Boom. Okay, and so one last thing, we need to complete the rule of 3, meaning if you have an object that has dynamic allocated memory, not only do you need to implement or overload the assignment operator, implement the copy constructor, but you also need to make sure you do this because, well, you have to delete the memory, right? Otherwise you have memory leaks. And so we already did it though, right? Because we have this code here. Edge cases and all, so boom, right? The reason the edge cases matter is because, let's see, if we don't have it, here it is, right? And so if I didn't have this edge case, and once troll order leaves scope, he will invoke his destructor, right? Which here's what it looks like. He invokes his destructor. Excuse me, if he doesn't have his edge cases, he would try to do the same thing when we looked at the assignment operator, where troll would try to dereference something he doesn't have to dereference in the first place. And so here's a place in which the edge case matters as well. But again, this sort of depends on a bunch of different things. The type of thing that you're dealing with, and potentially any sort of preconditions which would say that you didn't have to do this. But again, we don't have those preconditions here. And it turns out for these types of things, we do need to have this here just to be complete with regards to all the possible use cases that we encountered, in particular what we see being done here. Okay, so that's that. So hopefully this proves to be useful. Yeah, so if you have any questions, let me know. Molly ran away. She probably got tired. She probably got angry that I kept on talking about tacos without giving her any tacos, and so she went to, I guess, imagine she had tacos someplace. But yeah, so mull over this. This kind of covers a lot of ideas. I don't do anything. I'm not going to talk about the actual polymorphic behavior of functions here. I'll do that in a different video with something you already dealt with, because I don't want to kind of throw too much at you. That's not familiar. But yep, if you have any questions, let me know.